गुड मॉर्निंग। बुक नहीं लाया ना? नाइन्थ केमिस्ट्री और 6th केमिस्ट्री। मेरे को ध्यान नहीं यार, मैं आ गई ऐसे। गुड मॉर्निंग। How are you? All of you are fine?
Yes, ma'am.
Okay. Happy Diwali to you all.
Thank you, ma'am. Same to you.
Today I am starting new chapter and it is water. You all know about water. Yes, the topic is water. Lesson 3. Right? Without water, there is no life on earth. Water is the essential thing on earth to survive. Chemical formula of water is H2O and the chemical name is dihydride oxide, dihydrogen oxide, because there is 2 atom of hydrogen. So the name of water, chemical name of water is dihydrogen oxide. This is the chemical name. Now, what is molecular mass? How can we find out the molecular mass? Molecular mass of hydrogen is 1 and there is 2 atom. 2 atom of hydrogen is multiplied by 2 and the molecular mass of oxygen is 16. So the molecular mass of water is 18. Atomic mass unit. 18 atomic mass unit. This is the molecular mass. Now the structure. What is the structure of hydrogen and which kind of bond in this compound? See, this is oxygen is attached to 2 hydrogen atom, O, H or H, and this makes H2O. Now, what is the electronic configuration of oxygen? It is the atomic number is 8. Atomic number of oxygen is 8. The configuration of electronic configuration is 2 and 6. The outermost shell have 6 electron in its outermost shell. So it required 2 electron. This oxygen required 2 electron to make it octet. 6 plus 2 equal to 8. So what oxygen do? This is the oxygen and it has 1, 2, 3, 4, 5 and 6. 6 electron in its outermost shell. And in hydrogen there is only 1 electron is there. So it required 1 electron. Hydrogen required 1 electron and oxygen required 2 electron. To complete this, they combine together and form a structure. It's oxygen, This is. They share their electron, partially it with hydrogen and partially it with oxygen. And there is 2, 3, 4, 3, 4. 8 electron in oxygen and 2 electron in hydrogen. So this is the molecular structure of hydrogen in water. We all know water exists in all three states: solid, liquid and gas. Water is the most important natural resource. About 70% of earth is covered with the water. 70% of earth covered with water. But only 2.5% of water is fresh water, which can be used. Fresh water on earth, 2.5%. And in this 2.5, including the frozen water present on the poles and on glacier. This also included in this 2.5%. Of water exists in all three states: solid, liquid and gas. There is solid in the form of ice, liquid in the form of liquid water, and vapor in the form of vapor is a gaseous state. They present in free and combined condition. They both are present in both condition. In our body, 70% of our body is water only. 70% of body weight is water. If anyone is 30 kg weight, has the 30 kg weight, it means 21 kg is the water. Or water is not in pure form, it is included in the solution, cell shape and any other things. Water has the ability to dissolve many substances, wide range of substances in it. Due to this, it is known as universal solvent. Water is a universal solvent. It is known as universal solvent because of having wide range of dissolving capacity. It can dissolve many substances in it. Due to this, water is known as universal solvent. Water to form solutions, all solutions require water to make solution. For all the life processes, we need water in photosynthesis, in oxidation, in respiration. Everywhere we require water. Due to this capacity, dissolving capacity, it can dissolve many harmful substances. If it is dissolve all useful substances, then it is useful for us. But sometimes the capacity is changed into pollution because it can dissolve harmful substances also, which we cannot require. Water we use for drinking, it is purified water. There is three things. There is suspended particles, Suspended particles separate from the water by filtration. But in any dissolve impurities, remove from the water by distillation. Distillation is a method to remove all dissolved impurities from the water. If any germ is present in the water, all germs and bacteria, remove by adding chlorine. This is the method from which we can purify the water. If there is any suspended particle, we can remove it by filtration, dissolve impurities, remove by distillation, and germs and bacteria remove by adding sufficient amount or calculate amount of chlorine. Physical properties of water. It is tasteless, colorless, transparent, odorless. There is no smell in water. It is odorless also. And liquid. These are the properties of water. Boiling point. The boiling point is a point at which liquid can change into vapor form. This point is known as boiling point, and water has 100 degree. Water boil at 100 degree centigrade, pure water. Pure water boils at 100 degree centigrade. These boiling point affected by the pressure. It is affected by pressure. If we increase pressure, then boiling point of water also increases. So we can say the boiling point of water is directly proportional to pressure. If we increase pressure, the boiling point of water is also increases. The greater the pressure, the higher the boiling point. This is the principle by which pressure cooker works. Pressure cooker works on this principle, boiling point. We increase the pressure by putting lid on it, and there is a lot of pressure on inside the cooker. That's why it increases the boiling point, and material substances kept in this cooked easily. There is a problem in hilly areas because water boils at a temperature lower than 100 degrees centigrade in hilly area, because there is atmospheric pressure is being less in hilly area. Water boils below the 100 degree, because pressure being less or low. Due to this, there is a problem of cooking, because they require too much time to cook food. Mount Everest, at the peak of Mount Everest, water boils at 70 degrees centigrade. Water boils at 70 degrees Celsius. The boiling point of water also increases due to the presence of dissolved impurity. If any impurities present in water, pure water boils at 100 degree, but if there is any impurities are there, then the boiling point will not be 100 degree. It is more than 100 degree. This is all about the boiling point. Now the freezing point. Freezing point is the point on which a liquid change into solid. Freezing point of water or melting point of ice. Pure water freezes at 0 degrees Celsius. We know that water freeze at 0 degrees Celsius. The freezing point of water decreases with increase in pressure. Here is a something. Freezing point of water decreases with increase in pressure. Decrease. It may more less than 0 degree. It means -1, -2. As we increase the pressure. If we increase the pressure, the freezing point also decreases. Freezing point decrease as we increase pressure. This is the thing. Now, density. What is the density of water and how it affects the boiling point and freezing point? Density is a ratio of mass and volume. Ratio of mass and volume. This ratio is known as density. We can write this in this way. The ratio of mass and volume is known as density. At 4 degrees Celsius, water has its maximum density. Maximum density at 4 degrees Celsius. And we can calculate it like mass and volume. Mass, if there is a 1 gram mass, and volume it be centimeter cube. This is the mass and volume. And density of water. If we measure this in kilogram, 1 kilogram, 1000 kilogram equal to meter cube. Volume is 3 dimensions thing, so we can calculate the unit of density. Mass is 1 gram and volume is meter cube. If we measure mass in kilogram, then 1000 kilogram by meter cube. This is the density and unit of density. So maximum density of water is 4 degrees Celsius. 4 degrees Celsius. Water expand on freezing. We know that on heating, water expand and metal also expand. Same here, water expand on freezing. You should remember this. Water expand on freezing. If 92 volume of water, 92 volume of water, it expand on freezing. On freezing and change into 100 volume and change into 100 volume due to the expansion, and therefore with relative density equal to 92 upon 100.92. That's why water float on ice float on water. This is the reason of floating ice on water, because the density, relative density is changed from 1. Anomalous expansion of water. There is a unusual property of expansion of water. Unusual property of expansion. Anomalous, unusual property of. What happened here? Water has its universal physical properties. When cooled, it first contracts. When water cools, it contracts and decrease in volume, and do other liquid as do other liquid. All other liquid do the same process, but below 4 degrees centigrade. Water, see what happened here? Water contracts on cooling, but below 4 degrees centigrade it starts expand. And continuous do till the temperature reaches 0 degree, and expanding is continuous, go on till the 0 degree. And expand till the 0 degree centigrade. So what it is here, the point at which freezes into ice. At the 0 degree, water freeze. Here is a volume density of 0.99. Here is the density. And here is temperature. 5 5 minus 5 minus 10. Here is 4 degrees Celsius, 0 and 20. What is here? See, the maximum expansion at 4 degrees Celsius. The maximum expansion is at 4 degrees Celsius. After that, it again contracts. The property of anomalous expansion of water enables marine life. Due to this property, this anomalous property of water, marine life can survive under the water, because water has the 0 degree temperature at the surface of the water, but below the surface the water is not having 4 degrees Celsius temperature, and due to this water remains in the liquid form, and all the marine life can survive easily in water. When water freezes on the surface, it remains a liquid below the ice layer. This is all about the anomalous property of water. Next is density of water is higher than the density of ice. One more thing, density of water is higher than density of ice, and due to this ice can float on the surface due to this property, because density of water is higher than the density of water, and due to this water can float on the surface. This is all about the density and anomalous expansion of water. And the next is latent heat of fusion of ice. Latent means hidden heat. They have amount of heat. The latent heat of fusion is the amount of heat required to change a substance from solid state to its liquid state. Latent heat of fusion ice. Fusion ice means mixing of the combination of two states, solid change into liquid. At the state when solid melt or change into liquid, and the heat it required is known as latent heat of fusion ice. The amount of heat energy required by ice to change into water. Let's say ice change into water. Some amount, some heat, some energy it required to melt, and this amount of heat, amount of energy is known as latent heat of fusion. Specific value. What is the specific value? Its specific value is 36 joule per kg per gram. And if we measure this in calorie, it is 80 calorie per gram. There is a two different unit of measuring heat. Joule is also a unit of heat and calorie is also unit of heat. If we measure in joule, the ice required 336 joule energy to change into water 1 gram water. To change into 1 gram water into ice. Same here, 1 gram water required 80 calorie to change into water. This is known as specific heat. These are the specific heat in two different units. And when we remove this energy from water, then it change into ice. So the same amount of heat is released from 1 gram of water. The same amount, it is 1 gram of water. It required 336 joule to change into water. If we release, then here is same. If we give 336 joule heat to ice, change into water. This is the specific value of water or latent heat of fusion. It is on account of high specific latent heat. The high amount of latent heat solidification that lakes and water do not freeze suddenly. Due to this, lakes and water do not freeze suddenly. Latent heat of vaporization we will take tomorrow. Yes, the latent heat of vaporization we will take in our next class. Have you any problem? Yes? Okay. Have a good day.